Okay, probably we can officially start. Hello, everyone. I'm super happy to welcome you all to our tonight's workshop with Daisuke, data specialist at EPAM. My name is Sasha. I'm in charge of events and partnerships at Levagon Tokyo Coding Bootcamp. We run web development and data science bootcamps, and I see actually some of our alumni and students here joining this workshop. Super happy about that. So today we're going to talk about math. I know that a lot of people in the community that might be some of people might be a bit afraid of math, but here we are today to discuss the main concepts of math and algorithm, and to convince you that math is not that scary as it might sound. And Daisuke is here today to explain and discuss with you the main concepts, the main basic that you might know if you want to learn math for data science. Cool. So without you, I'm giving the microphone to Daisuke. Daisuke, feel free to introduce yourself. I would really appreciate it because sometimes we have people jump in right into the content of the workshop. So please start from the intro and feel free to go ahead with the workshop.
All right. Thank you very much, Sasha. To introduce, I'm Daisuke, and I'm a data specialist at EPAM. And I'm very glad that this Levagon's event to talk about the math for data science. So let me quickly share my screen and start talking about myself a little. So can everyone see the screen? Okay.
Yeah, we can see it, no problem.
All right, cool. So I'm Daisuke, and a little bit about myself. So basically, I did my Master of Science in Data Science and also the Artificial Intelligence at a school called the Data ScienceTech Institute, which is in France. So we have the campus in the Paris and also the Nice, which is the South France. And I studied there for the application of the machine learning. For example, I work with some hospital to make a prediction model for the patients of the heart disease syndrome. And then I worked as data scientist and also the deep learning engineer. That's what I refer to myself, but especially focusing on the computer vision. So this is the application of the machine learning or deep learning, and which was in the startup in Tokyo. So that was my previous experience. Then currently I'm working at EPAM Systems, which is the international companies where I work for the different clients from the education to the more industry for like some information company and so on to help the implementation of the algorithm and everything. So, and my favorite things, I have a lot of favorite things, but I really like the coffee, which is something I cannot go without. I like the coding, of course. I spend some time for the coding. I like reading too. I read a lot of books, which is kind of my hobby. And I love the music, especially the lo-fi music, which helps, especially for the studying or sometimes while walking. So let me explain a little bit of my mathematics background. So during my master, I basically learned the foundational mathematics to the application of the mathematics from the professor in my school. And these are the one of the professors that I learned from. So one is one guy, left guy is called Didier. He's more mechanical engineering. So he's a mathematician, but also in the industry, he's working for some companies to the some application for the like computational algebra sort of things. And this right professor, he's called Jack. He's actually very known professor as far as I know. He's one of the some research groups in France, and his study is more quantum mathematics. So his application goes towards the some physics, quantum physics, and also these two people are working for the climate algorithm, so to predict the weather forecast sort of thing. So that is the basic my mathematics background. So here, before I go deep into the mathematics, I just quickly ask you people, what image you have for math for data science. So please feel free either write on the chat or speak up with the voice. I'm more than happy to hear from you. All right. So statistics, yes. Algebra, yes, true. Characters, yes. Maybe metrics, yes. This is exactly true. Maybe like most of the people are already familiar with the mathematics. So basically, when you talk about the mathematics in the data scientists, these are basically the statistics and also the calculus and algebra and metrics, as all mentioned in the chat box. So it sounds a lot like when people talk about mathematics, it sounds a lot of subject, but if you focus on the something, it's actually quite simple, and you have to dig into a little bit of the spaces of the calculus and linear algebra, and also the optimization, and then you can quite a lot understand most of the let's say the roadmap of the mathematics in the data science. So here, I'd like to talk about the fun facts about data science. Oops. So the first fun fact of the data science is machine learning and deep learning are full of math. Oh, by the way, I'd like to talk especially with memes. So here you can see that if you look at the, for example, the algorithm or the artificial intelligence, those are basically a lot of the conditional, so mathematics like assignment coding, logics, right? And when I was in a master in the data science, basically the first class and second class was about the calculus and linear algebra. And the second fun fact, so many people hate math. And this is true that, as you can imagine, the machine learning, deep learning is very cool, that we have a lot of application. You can use it in many industries, and it's super powerful that you can implement this algorithm on the industries. But on the other hand, this requires some knowledge of the mathematics, and people don't usually like it. Like people like maybe programming, Python coding. But when it comes to the mathematics, many people actually say, yeah, I kind of know the math, but yeah, I kind of know. And that's actually true. And yeah, about data science. So next fun fact, build a model from scratch requires the substantial knowledge. This fact I really want to emphasize. So when you become the data science or either deep learning engineer or whatever you want to call yourself, you might have the opportunity that going to build some algorithm for the companies. For example, if it's the financial companies, you might go into build the time series algorithm to predict the next stock market price, or maybe now about the cryptocurrency. So maybe the prediction model for the Bitcoin or Ethereum or something. So in that case, you probably not implement from the scratch. And the reason is that when you try to implement everything from your own, there are a lot of assumptions that you have to make. And this is one of the most difficulty for the machine learning and deep learning. And as you can see in these memes, so first assumption you make is, so my model is linear regression model. So linear regression is a basic model for the machine learning or statistical models. But then you realize that there is the outliers. So outlier is the some, let's say, the data that in some, okay, let's say America, if you live in a city where the Jeff Bezos lives, the average incomes go to extremely high. Is that because the Jeff Bezos income is extremely high compared to the other people. And this is called the outlier because the value itself is substantially high to the other average. So when you make a linear regression model, if you have these outliers, basically you cannot make the assumption that the model is it's called the IID, independently identically distributed, and that assumption will be broken because of these outliers. And even after the you consider the outliers, then you get the correlated feature. And this correlated feature means that when you make some models, let's say, okay, so when you make the model for the credit rating, so whether we grant the credits for the certain customer in the bank, you have a lot of data about the their backgrounds, their maybe status, income, some educational statistics. But if those one of those we call it variables are highly correlated, then the model cannot make a right prediction. Why? Because these correlated features are going to work for the same patterns, which means that the prediction model cannot work for the one pattern because two variables work kind of same way. That makes a model difficult to predict correctly. And then the next pattern comes that the prediction is non-linear. And this is quite a common pattern. So you try to predict some model. Let's say you have some like a linearly related feature, and you try to just modelize this one. But then the assumption is wrong because what you're trying to do is not linearly related. Sometimes what you want to try to predict is highly non-linearly related, or like a more complicated pattern when it comes to the higher dimension, because you have more variables, and usually in that case the prediction is much more complicated. And this is also the other pattern that I want to emphasize. So when you try to work as a data science or deep learning engineer, you most of the time going to face with this problem. So you know the machine learning, you know the Python, and let's say, yeah, you know the cloud. Then your employee gonna ask you, so can you implement the Kubernetes? So the Kubernetes is basically the like a Docker manager. So the Docker is when you make an algorithm, you have to deploy the model on the system. And the Docker is the independent environment that you can run all the machine learning algorithm separate from the other dependencies. So you're not going to have any dependency error. And Kubernetes is one of the components. But because of this ambiguity of the data scientists and the data engineers, machine learning engineers, deep learning engineers, people get very confused what you can do and what you cannot do. So I personally recommend, if you have some additional ability, it's always nice to reach out to the how you deploy the model, how you implement them, like using Docker or the Kubernetes. I think I skipped sometimes things. Yep. So first fun fact. So most of math is behind the package and you don't have to implement them. So this is also very important. So when I first working at a startup as a data scientist, I was really expecting to write everything, like, because I was so into the computer vision. I was waiting to write all the algorithm from scratch and write every script, make some small modification for the algorithm to make my own model. But when it comes to the work environment, let's say you work for the startups, usually there's not many time for you to implement everything from scratch, especially in the startup. You have the, let's say, some deadline that you have to submit your algorithm. In that case, you have very little time that you make a model on yourself. Besides, when you try to make all the models by yourself, as I mentioned already in the last fun fact, there's a lot of the assumption that you have to make. And this assumption is based on the data, so the nature of the data. So if you're in a financial industry and if you're in other market industry, the data basically, the nature of the data are quite different. So what people do, what industrial people usually do is we all use pre-made package. So this one is called the Keras. Keras is one of the package made by the some Google's guy called the France Choret. So this is a very high-level API that you can quickly implement deep learning algorithm. And I will emphasize that most of the time you're going to use those high-level API for your implementation. So this is another memes. Personally, I find this is very interesting. So yes, as I explained, that you're not going to implement most of the algorithm by yourself. And a lot of the cases, only you have to do is, this one is from scikit-learn import linear model. So this one line of the code allows you to import all the algorithm, all the pre-made model, basically created by the scientists who have a lot of knowledge for the some assumptions. So I would highly suggest that using the package would help your life easy in the workplace. So this is a final fun fact. So I talk about a lot, we don't actually need mathematics to make a model because we don't need to make a model, or most of the time you have to only import the scikit-learn or Keras. That being said, knowing mathematics will definitely help data science. Why I mentioned this is that, so when I was working as a computer vision engineer in a startup, we are trying to deploy object detection model. So it's a model that detects the people's, let's say, the people's count. So how many people is there? So this is a more object tracking, but we are trying to make this algorithm on the edge device. So I put with the camera to implement in a real situation. And what happened is that when we tried to make this model, so model itself was quite a memory heavy model. So we have to actually make a lighter model. So when you try to make it lighter, usually you reduce the layers of the deep learning algorithm, or you just cut some part of your algorithm. And when these things happen, we had a lot of program of the where to cut off and where to add on, and how you make it correct, and how you manage to work everything fine. And in this case, you definitely need the mathematics knowledge, because if you don't know the mathematics, you can modify your algorithm, but you don't really know what you're modifying. So I emphasize that the importance of the some package that you can use, but at the same time, knowing the foundation will definitely help data science career, and also as a troubleshooting a lot of times. So these are some textbooks that I recommend for the data scientist. The left one would be the quite new. It will be published, I think, this year or maybe the next year, which is from the O'Reilly, one of the very famous publishers. I took a look at this book, and it's a very foundational, and yet they explain all the important concepts. So like a calculus and algebra, probability and statistics. I'm not going to talk about probability and statistics, I'm afraid, because of the time limitation. But I would definitely recommend to take a look at this book. And the right one is one of the most famous books. It's called Mathematics for Machine Learning. it's a little more difficult. You have a lot of linear algebra, you have a lot more mathematics notation, so it makes you maybe a little tricky, but it's definitely the great book to go for taking a look and dig into your mathematics journey. So these two books are also quite known. The left one is a deep learning book, which is made by the Ian Goodfellow and Yoshua Benjur. Basically, these are one of the founder of the deep learning. And this book explained almost all the concept of the artificial intelligence. So it's like the beginning of the artificial intelligence, how you make this model and how the artificial networks works. And it's a really low level mathematics, so you can see almost everything, how it works. And this right one, this is called Pattern Recognition and Machine Learning. This is also a very famous book. So this one is a little different from the left book in terms of the approach for the problems. So because the left one is focusing on deep learning, but the right one is more focused on the statistical models. So if you're familiar with the Markov models, some stochastic model, there's on this book. If you know some clustering model like K-means algorithm, PCA for the dimensional reduction, the right book will explain to you a lot of those concepts, and you can go quite far, very deep knowledge. So this is some outline for the next session, but before I move on to the next session, I'd like to maybe answer, see the chat box. Okay, thank you for the message. So, so I got a message personally. Thank you very much. So this is about the math, and because the math is very huge subject for machine learning data science, which concept math we have to learn, and what is job of the data scientist? Very good question. So first thing, math is very huge for machine learning data science. Which concept of math we have to learn? This is really depends on the application you're going to make. For example, if you like to make some computer vision algorithm, you definitely need a linear algebra. And it's because almost all the artificial intelligence neural network model requires to have the knowledge of the linear algebra. And you have to make the model by understanding how the higher dimension works. Because usually, if some of you might know the convolutional neural network, which is the three-dimensional model that you can capture the colored images. And this definitely requires linear algebra. But when it comes to the, let's say, recommendation model, you might need a different mathematics. Let's say you might need to, well, of course, you might need to know the linear algebra, but you also need to run about more probabilistic model, because sometimes the people use a probabilistic model like an EM algorithm or some higher probabilistic model. And that is the kind of the trend that I see these days. So it really depends on what you want to focus on. And maybe you can check on the internet also what kind of mathematics you need when it comes to the industry that you're particularly interested in. And the question about what is job of data scientist. So it's a lot of the thing, I would say. So basically, the people don't know much about data science, right? So what happened to you is you are much more knowledge than any other people about data science. So when you work for data science, people ask you a lot of things. Can you do this? Can you do this? Sometimes it's just a simple SQL. So it's, can you write down the SQL code? But sometimes maybe they ask you, can you make some infrastructure, so that like a cloud, and can you make some computer engine? And of course, sometimes you have to write the algorithm to make a logic of the how things works. Again, this is really depends on which company you work for. But if you work in a startup that is highly motivated and try to implement new model, you might have to implement the model from scratch. So in this case, you will go through the research paper and you understand the paper and try to implement in whatever language you have, the Python or R. For the additional question, yes, data science first. Yes, I've already read this book too. This is very interesting because data science from scratch book is everything is written in Python. And when I mean the Python is they barely use the package to implement some algorithm or the statistical model. So this guy, I think the name is Joel. He's a very good engineer that I think he has a long experience in engineering industry. So he knows how to write a code in the Python. So if you like to more focusing on the kind of engineering side of the data science, I really recommend this book because you can really learn how to use the Python itself without using any package like a Keras, TensorFlow, scikit-learn. Okay. So do you have any question? If you have any question, I'd love to answer any question. Like I can see my friend Chris.
Daisuke, if you have any private questions, could you please read them aloud? Because people might not understand what the question is about first, but you're already answering. That would be cool. Thank you.
I'm sorry.
Sorry.
I was a bit afraid because this message came as the direct message, so I'm not sure if I can read out or not. But yes. So
well, if people are asking about your, phone number, this is maybe something that you talk about. But if they're asking something about related to today's content, definitely, please.
Yeah, sure. Okay. So what we're talking is basically there's a book, one book called the Data Science from Scratch. So it's also the reference from the O'Reilly, like this one. And this book, Data Science from Scratch, is mainly focused on the Python. And that was the question, like whether it's good for the beginners or not. So I would say if you like to run the coding, and if you're the beginner for the Python, maybe this is very good to learn both the Python and the coding. Yes. So the next question is good for the beginner. Yes, I would say definitely yes. It's an amazing book. He's a bit have a character on himself. He's a little strange guy, but he's very good at coding, Joel. All right.
Cool. I mean, maybe we can proceed, and if people have any questions, let's probably leave them for the end of the workshop. What do you think?
Okay, sure. So next, I'm going to move on to the practical side of this topic. I'm going to share this notebook to everyone in the meeting. I talk about a lot of the gibberish so far, but please don't be frightened. This is very overview of the mathematics in the data science, and all the things you have to do is much less, to be honest. I just try to describe what it's like as an overview from my experiences, but you will end up doing some part of this talk. So please don't worry. So I'm not sure if everyone can access to this notebook.
Yeah, and we can also see it on your screen as well.
Okay. So it looks fine at the moment. So as for the heads up for this notebook, if you like to implement some of the things, you have to first learn this. By the way, this is called the Google Club, which is the like some notebook like a notebook you use in the school, but for the coding and also for the some notation. So you can use both for the coding and also write down some memos. And this is made by Google, and it's all free. You don't have to pay anything, and you can use computational power from Google. So it's nice. And to use this notebook, if you like to implement, you have to first learn this cell. And this is installing some Python dependencies. So as I explained before, you might need some Tensorflow, scikit-learn, which is the algorithm that scientists make. Basically, this will allow you to install those cells. And after that, you can go to the next step. So I'm actually quickly go through those little high level of the mathematics, or like some abstraction of mathematics. I really want to focus on the visualization part of the mathematics, because some people refer mathematics to the baseball. Well, I never played the baseball, but I know what it's like to play the baseball. So when you play the baseball, you don't think how to throw the ball, or how to hit balls. Maybe yes, you think a little bit, but you don't really calculate. Okay, so I'm going to hit this ball in 5 seconds with this direction, with this power on my hands or something. It's rather intuitive, like because you get to know how you play it. And I think the mathematics is a kind of same, that you're not going to learn everything by writing some complex things, but rather looking at how things work, what it's like, that what is the calculus really, that is more important. So this is my approach. So first thing, I'm going to talk about differential calculus, which is a fundamental concept of the machine learning, data science, and AI. What is differential calculus? This is my answer. You can see this weirdly moving. Oops. Okay, weirdly moving some lines. In mathematical terms, it's called the tangent function. The tangent is just like this, like some lines in like 90 degrees with the point that's the thing's in. And this is another example that's showing this tangent. And now the point is, yes, I know that this is a tangent line, and I know that this 90 degrees like across this point, but what is so important of this line? Differential calculus. So what is so important is that this will allow you to understand which direction you go. Okay, imagine that you're in a mountain and you're working in a big mountain. And the mountain is shapes like this, usually like a concave shape, right? And let's say you want to go to climb up, then you have to find a direction that, oh, this is obviously not for the climb up. Well, this way is actually have the stairs, so I will go up with this direction. Differential calculus is basically this. Differential calculus is a tool that finds the direction to go either upward or the downward. So I want all to imagine this one is a mountain. And when you find this tangent line, basically this tangent line is like some compass that tells you that which direction is the steepest way to go down or steepest way to go up. And this enables to some algorithm to move around on this mountain shape. It's called a landscape. And if you want to write down this, what I explained right now, the mountain story, you have to understand all these mathematics like ax, exponential a minus 1 and some things. And these are some rules. And I would say, yes, good luck to remember them, but you might not use most of the time. But again, it's always nice to remember. So this is just some basic of the calculus rules. Again, I'm going to skip this part because this is not so fun, important for most of the people. And well, it is important, but not every time you use. And these are the same. There's some rules. You have basically some mathematics function, say like x plus 5x plus 2, and then how you get the derivative. How do you get the direction that you're going to down or up, sort of thing. And that's all about it. And next one is called integral calculus. And this is the kind of control related to the differential calculus. So what it's doing is integral calculus use okay, so the proper definition is the assign number with the function in a way that describes displacement, area, volume, and other concepts that arise by combining infinite small data. This is just so mysterious words that is explaining detail. But basically what it's doing is this is used for the approximation in the area or the volumes. So when you have some, let's say, this is some lines. Okay, this can be the mountains, and you try to measure the what is the volume of these mountains, and maybe there is a lot of way to calculate, and one of the way can be the integral. So integral is set some boundaries, and this is a closed boundaries that you can measure, and you make some shape, and A to B, for example, and then you get small portion of the part in the each areas under these shapes. And when you try to do this to decrease the each square areas smaller and smaller, so this is like a steps, like you make it smaller and smaller, the approximation for the function will be extremely close to the real volumes. This will be good to understand some application. And one of the application is called the EM algorithm. I'm not going to go deep into this algorithm. So this is mathematics formula you can ignore. Basically, what this doing is it calculates some values in data. And first you see these two data. And now you can see this red circle and the yellow circle. It's kind of try to capture these two categories. So this is called a clustering algorithm. And this is one of the huge applications that the integral are used. So if you're interested, you might go and take a look at some reference book as well. So this is an application like a mountain you have, and you calculate the part of like the lower bound and upper bound. So it's like where to where you measure, and you make it this, it's kind of like a square shape to the smaller and to make it more approximate. I make it some toys that here. This will allows you to use some value change and makes you the different shape of the approximation. The thing is, as a head up, you have to run all the code beforehand, like everything, and then you come to this part and you fix some, adjust some values, then you run, then you can use a different shape. I prepared some models. So next thing is again, this is very important thing, linear algebra. So this is the proper definition of linear algebra, but I don't really think that's necessary for most people. So the idea of the linear algebra is, so imagine that we are living in the three-dimensional space. So or maybe it's surprising that the people start saying, yes, we are living in three-dimensional space. Yes, this is quite a strange way to put But basically, the idea of the linear algebra is, so we have this some space in the, let's say, our three-dimensional space. You apply the, let's say, some filter, like any filter, movies filter, like you have a smartphone and you make it like, how to say in English, it's like a moru. In Japanese, it's like makes you more fabulous. Moru is like using the filter, right? This is kind of similar in a way that the linear transform, it's called a linear transformation. Linear transformation uses algebra to transform the original shape into the different shape. So we are living in this three-dimensional space, and if we apply some filter, sometimes you look fabulous, but sometimes it makes you funny, like some funny filter that is on a messenger sort of things. And this is the idea that you apply some filters and to transform the original shape. And this is used a lot to make some approximation in the machine learning or neural network, artificial intelligence. So I prepared a lot of the mathematics here, but again, I'm not going to dig into so much details. This is basically how you implement linear algebra in Python. And I use the library called the NumPy. NumPy is again the scientific library made for mathematics, but especially for the linear algebra. So these are all the basics that I think quite fundamental and nice to know. But I believe this is quite comprehensive. So if you have time, I recommend you to take a look. But that's all. Then here comes this called the gradient descent algorithm. So basically this one is the application of the different calculus. So it's like a mountain and go downward or upward. So now you have this shape. It might look a little more like a mountainous shape in the way that you have a different directional shape and like where to go, where is the steepest way to go downward. So this explains how you go down and climb down the mountain in the fastest way. Basically, neural network is like the same. So what it's doing is, when you make some algorithm, usually your algorithm is extremely poor. When I mean poor is poor performance. So you try to model some dog, but it's a muffin, and it's a quite common thing that model performance is poor. Why? Because you don't find a good approximation for the correct, let's say, the image. And what you do in the poor performance is you make a better approximation. And what means the better approximation is find the bottom. So you basically go down to this hill. It's called a cost function. It's some landscape that some algorithm use to measure how good your model is. And this means lower you go, the better your model perform. But higher you go, usually the poorer your algorithm perform. And when you try to do, when you work as a data scientist, what you do is you find this lowest part in your mountainous landscape. And when you try to explain this in a graphic, it can be like this, and blah, 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 another algorithm, and blah, 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 again, the neural networks, that if you're interested, you can take a look. Yes, so I talk a lot about the mathematics and some gibberish again, but now I want to go to more practical part. And here I bring one data set. This data set is called the Data Science and STEM Salaries. So basically what this data set says is that what is the salaries in the tech companies if you work for the either data scientists, major engineers, or maybe some market and sales. I find this is quite interesting. So this is the overview of the data set. You have some company like Oracle and Amazon is a big company. And Apple, yes, Apple is a big company, and Microsoft, of course. And you can see the title of the people. Oh, by the way, these are the timestamps. So when these people let go of those values. So it's like 4 years ago, 2017. And the title, product manager, software engineer, product manager, software engineer, blah, blah, blah. And their salary. For example, this guy has $127,000. So in Japanese yen, it's like a 1,300 It's quite high. And he's a product manager. Oh, sorry, it's actually here, the base salary. This is the compensation, so it's the total. It's around 1,000,000, yes, 1,000,000, around $100,000. And these are the years of experience, how long they work for before. So this guy is actually amazing. He only works like 1.5 years, according to him, in his entire career at Oracle. Now he gets almost $100,000. It's quite a lot. So this is the more data that I picked up. It's highest average salaries in the top 20 companies in the dataset. So as you can see, among this dataset, the highest salary is in Netflix, which is almost 400,000. So in Japanese yen, it's like 4,000. I'm very surprised when I first saw this. It's because the Bloomberg or the other companies like Squarespace has a quite high salary, like Sanzeman, like 300,000. Salesforce is very good, but Netflix is extremely high. It's I'm very surprised because this is not about highest salary in the company. It's the average salary. So if you check everyone's salary in the Netflix and you divide it by the number of the people work for, usually people get like 400,000. And I see more details. And this is the distribution of the Netflix and their salaries. So around here, this is the average, how much the people get the salary in the Netflix. And this is, by the way, called a box plot to measure some values in distribution. So the data's how the data distributes. So what is the highest number of the salary, or what is the lowest number of the salary? So as reported in this data set, the highest salary is almost goes to 1,000. I'm not even sure how to say 1,000,000. So it's like millionaires. And this is 1 year's salary in Netflix. And most frequent company in this data set, it's Amazon, Microsoft, Google, Facebook, Apple, Oracle, Salesforce, Intel, IBM, and Cisco, well-known companies. Now I got interested to look at some data in the those people called the GAFAM or the GAFA, Google, Amazon, Facebook, Apple, Microsoft, and I checked their data set and what is those companies are. And here I visualize their salaries. So it's again the average salary in each company. And what I found is compared to the other companies, those companies gives relatively low. I mean, it's quite high, but relatively low salaries in average. And among those companies, the highest salary is Facebook. And I'm surprised again that the lowest salary is actually the Amazon. And I think Amazon has very competitive market in the industry, but I think at the same time they have a lot of employees. So in average, the average salary becomes kind of low. Yeah. And by the way, also I find something interesting. So there is also some data that how many percentage of the people are from the some degree. So if you go through the master or the bachelor, doctor, all the high school, some college, things like that. And it was not surprised that the Google, for example, is relatively high. They hire a lot of PhDs, more PhD than the other companies. Yeah, and also this is true that for the Apple, they hire more PhD than the other companies. But in general, I also see many companies like equally hire the people from the bachelor degrees. So I'm not really thinking having the degree doesn't make a difference if you want to work for those companies. This is some data for the your position. So if you're the software engineering manager, relatively you're the highest salary in the all these positions that you can find in this data. And technical product managers, and I'm also surprised that marketing has quite competitive salaries in the tech industries. For example, if you can use cloud computing, would be, I think, the solution architects. So like AWS, GCP could be this, but it's actually the marketing has more income, high income. And high income means it's a very good position, competitive position. So it's actually interesting to see this. Yeah. And you data scientists are less salary than the marketing guys. So you are in the middle of this landscape. You have engineers, marketing, and yeah, but still it's pretty good. It's like 125,000 more. It's actually 140. But if it's about the US data, so in Japan, I think a little less gonna be. And then it follows like a sales, recruiters, and business analysts. And the business analyst is like a data analyst. Yeah. And these are some other information that I found in this data set. So this explains your salary and years experience, like are they related or not? And this shows little, like slightly it's related, like if it's almost this line, it could be highly correlated. But as you can see, it's like higher your years of salary, you basically will slightly increase. But you can find here is there is just two guys who has extremely high income, and also there is one guy who extremely long career experience, like almost 70 years in the one company. So I decided to take a look at these people. So it turns out that those two people who has the highest salaries are one from the Squarespace and the other from the Microsoft. One that he's in New York and the Microsoft guy is in the Redmond. And yes, I understand the experience is quite long, 7 years, and the Microsoft person is like almost 13 years he worked in this company. But what I see salary is it's again, this number is a US dollar, so you multiply 100 to calculate the Japanese yen. It's almost like 1 million, 1.6 million for two person for 1 year. This is very surprised. This is impressive, and especially he is only 7 years experience, and now the salary is 1.6 millionaire. And also I see this most experienced person here, and it turns out he's working at the Disneyland, so the Disney, and he's a product designer. I'm not sure this place is, I think, the US, the couple, and his experience is like 70 years in the Disney. It's impressive. Yeah, the salary is like almost 100,000. Yeah. So that was the basic data. So I think we're running out of time a little, so I'm going to expedite this notebook. So after that, I explain some of the other little mathematics, how you actually calculate to go lowest steep in the like a mountain we've seen. And this is some mathematics that I load. And again, it's very basic. That is like the least amount of math that you need to know to calculate. And then I make a Python code. So as you see now here, this is basically the artificial intelligence. Well, of course, it's quite an approximation, and I made it quite easy, but it's a neural network algorithm that I wrote with a Python. So what is happening is when you do this algorithm and you do some computation, it shows those numbers. And this number get like smaller and smaller. And what it's doing is you go to the bottom of the mountain, you find it steepest direction, and you go to the lower and lower. And if you do that, you get the same values. At the beginning, it's like almost 170. It goes almost 0 at the end. And this explains how good your model became before, compared to the before. And I wrote in another way. And this one is using the linear algebra. So it's the same algorithm, but the structure is a little different. And I just do the same thing to find the steepest way to go down. And repeat almost 100 times. And after the 100 times, your, it's called the loss, will become extremely low. So like you almost reach to the bottom of the mountain. And finally, I use, as we saw, the Tensorflow. So we said before that it was a quite long call, that what I wanted to introduce in this Math for Data Science is this is all you do as data scientists in the workplace. You don't have to write anything from scratch. You only have to use TensorFlow, import keras, and you write a little code like a 3 code and 4 code, and then it nicely shows artificial neural network algorithm. This one is not so good because the loss is not so decreased, but make a little different one that you make some adjustment in this neural network algorithm. And now you have a better approximation. So it goes down, down in the mountain hills. And then finally you get a lot of low values, which means that you're really coming to the bottom of the mountain. So that's about it. Like I wanted to explain that mathematics is quite interesting and can be quite tricky, but all you need is some idea how it works and what it is like. And most of the time, it's quite important to understand image, like a baseball, to get some abstract image of mathematics. And here's some reference that you can look up. Some videos nicely explain how the calculus work, and StatsQuest explain the statistics very good. Article about the gradient descent, and also I have some books of the mathematics, machine learning, and deep learning, and I put also about the data set in a data resource, and some of the online courses. So I was a little hasty at a later part because of the time, but I hope I was intuitive and understandable.
Cool. Thank you so much, Daisuke. We are running slightly over the time, but let's probably have a couple of minutes for questions. So we have, I don't know, but you might got some private questions, but we have a question from Tina. Any outlier there? I think the question was directed when you were explaining about the salaries, and you said that Netflix has very high salaries. Do you think it's an outlier, or it's like?
So, okay, yes, that's a good question. Let's go back to the Netflix part. So as mentioned, outlier is very high, like Jeff Bezos, right? What you see here is outlier is only those people, right? Just like small dots are outliers in the Netflix. And these people are average people. So 400,000 US dollar salaries are like everyone working in Netflix. And that's mind-blowing statistic I found out.
Cool, thank you. Do you have any questions in your private channel?
Any outlier? Sally.
Hi, Daisuke. Nadia here. I don't really have a question, but it's just more of sharing and comments. It's actually really assuring that you mentioned about, it's kind of, while it's important, it's also not necessary to know like 100% what goes into the whole maths and the concept and the idea, because I just started the full-time data science course, and I do find myself having a little bit of struggle when it comes to stats, because I didn't do much of stats back in uni. So having to learn all of this, it's quite a challenge, but also very assuring to hear it from you that, yes, it's important, but there are a lot of things that sort of like, when you import, all of the packages and modules and whatnot. So that's really helpful. Thank you.
You're very welcome. I'm very glad to hear that, because I was also the learner for the data science learner, right? And I had a struggle for, I have to learn this, I have to learn this, I have to learn everything, and I'm so overwhelmed. But in the end, if you work for data scientists, you only do a little part of what you're doing in your learning journey. So I very emphasize on this part.
Nadia is killing it. She's joining our data science bootcamp remotely every day. Yeah.
Oh, wow.
Yeah. I'm joining in from Melbourne, so it's like 10 p.m. right now.
Oh, wow. Thank you very much.
We do have another classmate, Larry's here as well. He's actually joining in from Alaska. Sorry for the shout out, Larry.
Wow, that's very cool. By the way, my friend Chris, the guy on the camera, he's in you're Australia, right? You Sydney. Your mic is off, Chris.
Hey guys, yes, I'm in Adelaide.
Ah, Adelaide.
Yeah, so it's 30 minutes earlier than Melbourne. My time is 9:30. Yeah.
Ah, okay. Thank you. Thank you for joining.
Thank you.
Ramosi.
We have a question from David. What is the hardest parts of being a data scientist?
Hardest part of being data scientist. I think it's I think the hardest part is to find a recruiter who understands data science. Because most of the time they don't know what you're doing. And most of the time they don't know a lot about data science. So yeah, you have to find a good recruiter. That is hardest.
Also in the business world, the data science is known as AI. So a lot of people actually don't know that the data science is a name for AI. I mean, so they look for someone in the AI world, but not the data scientist. This is my question about Japan, but maybe you have some other insights, Daisuke.
Yeah, I think in a way it's true because yes, you can use artificial intelligence. So it's true. But yes, I mean AI is some of course something behind, right? Like AI is not some imaginary amazing thing, like not magic, right? So yeah, that has like some slight gap between the people who want to hire you as an AI data scientist and what you can talk with them.
I also have a question in the private from Sohail, I think. What is the main application of SQL in data science?
This is a very good question. Why? Because SQL sounds a little archaic. I mean, little old school. Maybe 10 years ago, people write SQL, whatever. But now, as far as I know, in the community of this data science, it's quite hot. Why? Because if you go into the data world, you might hear about the Spark or the Hadoop. Those are used for handling big data. The big data is massive data, like 1 billion data set that Google might use. And when you try to do this only the Python, it's very possible because of the quantity of the data, but SQL can handle it. Why? Because it's made to deal with the massive data. And one very interesting thing is that Google make one algorithm is called a BQML. It's the BigQuery is Google's SQL engine, but they implement machine learning algorithm inside of the SQL. So you can use the machine learning with the SQL, and it's kind of trend that I see these days. So yeah, that's my answer.
Cool. Any other questions? We have still a couple of minutes left. So if you guys have any questions, feel free to write in the chat. And otherwise, we will wrap up the event and let our Australian attendees go and take their rest. Because it's 10 p.m. Daisuke, is there any way to contact you or like follow up maybe your update?
Sure, for sure. I'm just going to write my mail address so you can directly send me a message, like anything. If you have any question about data science or anything about job hunting or about French, or because I little speak French, about your hobby, or like you're highly depressed, I love to talk any topic because yeah. So you can contact me via this address.
Cool. Cool. Then probably let's wrap up. Thank you so much, Daisuke, for the very informative and interesting workshop. Thank you. You nailed it. And thank you for everyone thank you everyone for staying with us until that late. Yeah, it's 8 p.m. in Japan, but 10 p.m. obviously in Australia and Alaska. Oh my God. Love it. Thank you so much for joining, and I hope that today's workshop shed a little bit of light for some of the aspects in data science that you would like to know. So yeah, we have a mail, Daisuke, and also I send one more time. I will send a link to the collab where Daisuke keeps all the code that he shared today during the workshop. So feel free to click. It might take some time to load. For me, it took, but yeah, definitely it will load. I also got a question. Do you have a Levagon in India? Unfortunately, we don't. I'm so sorry. The closest Levagon to India will be in China and in Singapore. But you can always join remote, like we have Nadia and Larry joining us remotely. Cool. Thank you so much again, and I wish great evening for those of you based in the Asian time zone. good night for those based in Australia, Alaska. Good afternoon, good morning for those who are based in different time zones. It was nice to have you all, guys, and looking forward to seeing you for our next workshops. Thank you, Daisuke. Looking forward to seeing you for our next workshops. Maybe I will invite you for our different workshops for data science or something else. Really
all
cool.
right. Thank you. Thank you, everyone. Thank you, everyone from across the world. I appreciate your attendance. Thank you. Merci. Thank you.
Bye.
Bye.